Welcome to the EIGRP Raceway. In the left lane is EIGRP clocking in at 150 milliseconds convergence time. In the right lane, its competitor is rounding the bend, and OSPF crashes into the grassy knoll. it's not that I'm against OSPF. I love OSPF. It's great. But I'm telling you, once you get into EIGRP, it's so simple and yet so powerful. It's like, come on. Why would you not use this protocol? I mean, come on over to the Cisco side, everyone. Why do you need third-party routers? Third-party routers. I mean, when you have to classify something as a third-party router, what's that all about? Anyway. As you might have guessed, this is the EIGRP configuration nugget. I've got this topology configured. I've set it up in GNS3. Only thing I've pre-configured is the IP addressing. You can see the black box over in the black box. What am I talking about? The backbone router. Corporate network over on the left-hand side. I've pre-configured all of these networks on it. We've got basic IP connectivity. Of course, the backbone router (BB) cannot ping beyond these two devices because it doesn't know about them. We haven't set up any static routes, any routing protocols, so let's get going. I want to bring up the GNS3 configuration just so you can see what I've got going here. Just familiar, I mean, it's the same thing as this, just not as glossy. Just so you can see the port numbers. If you need to pause and just orient yourself, feel free to do that. I'm going to start off on the branch offices over here, router 2, router 3. Just get a little simpler before we get into the corporate network and get some base configuration down. So let's hop up here to router 2. Router 2, I'm going to go into global configuration mode and type in router EIGRP, and we follow it up with an autonomous system number. Now, all the routers in your organization have to use the same number. This is not like the OSPF process ID. This one matters. So if you don't know what to use, and this is just now rolling now, just go in and pick one, and just remember all the other routers have to be in autonomous system 1. Now we come into the network statement. The network statement allows it to remember those two things. Think back to EIGRP1. When you go on to a router and you type in, let's just say network. Let's keep it simple. 10.0.0.0. Right? When I type that command in, what the router does is say, okay, I'm going to go, well, with EIGRP, first off, OSPF doesn't even let you type it in that easy, but EIGRP will. And it'll say, okay, you must be thinking in a class full state of affairs. So I'm going to look and say, well, 10 is a class A address, so I'm just going to zone in on that number 10, and I'm going to look at all of my interfaces on here. And I'm going to say, okay, well, this one starts with the number 10, and so does this one, and so does this one. So I'm going to do two things. This network command is bizarre because it does two separate functions. One, I'm going to send hellos out on those interfaces. I'm going to try and form neighbors on every interface that starts with the number 10. Right? The second thing I'm going to do is advertise any network that starts with 10. So it's going to look at all of its interface and say, okay, well, so let me just put advertise networks, right? It's going to say, well, I've got the 10.1.25.0/24. So I'll start advertising that to all the other routers. Now, big misnomer, and this caught me when I first learned it, and probably one of the most confusing. I'm like, okay, so if I type in the network 10.0.0.0, is it actually advertising 10.0.0.0? Right? Is it actually telling other routers, hey, everybody, I know about 10.0.0.0? No, it is not. That is considered a summary route. So in the EIGRP, it's going to look at the interface itself and be like, oh, this is 10.1.25.0. Okay. So class C. I see the subnet mask that you've configured on the interface. Oh, look at this. It's a /30 or 255.255.255.252 subnet mask. So I'm going to advertise that network correctly, right? So I'm gonna let's start off router 2. I'll just go as simple as it can be, right? I'm going to type in network 10.0.0.0. Funk. That's it. I'm telling you, EIGRP is simple. It's like there's no areas to worry about, no area border routers or summary points or blah, blah. I mean, all the OSPF complexity, right? They wanted to make it easy, and they did. Now, I will say Cisco did make, well, I don't want to call it a mistake. Cisco never makes a mistake. But they made a choice that I would not have made if I were to create EIGRP, and that is by adding a feature known as auto summary, right? So what auto summary does is cause EIGRP to try and be friendly for you. Meaning, whenever it reaches a boundary of a network, a major class of network, it's going to try and auto summarize. Perfect. It's like the screen was it's as if I would have planned this. I've got the backbone router over here, and take a look at this. This is what? A class B network, right? 172. Look at that number right there. Well, that falls between 128 and 191. That's the class B range. So by default, it's 172.30.0.0/16, right? Class B, that's its default subnet mask. So what EIGRP will do is it will look and be like, oh, okay, well, it looks like I've got everything 172 over here. And I've got all the 10 networks over here. Okay, we're moving between major, like these are not 172.30 networks, right? You catching that? So what it will do is it'll be like, oh, okay, well, I'll just go ahead and take all of these, like, let's just hide all that. Let's go ahead and automatically summarize this back to 172.30.0.0/16. So the intention is good because Cisco's like, man, if you design your networks well, this can just kind of take care of all the summarization for you and make your routing tables efficient and all that stuff to where these guys just get one route in their routing table to represent all of those networks, which is great. But the problem is people don't design their networks well all the time. And so, let's say down here, I decide to, create a couple other networks, or maybe I have this grand idea. Let's go this route. This would be even easier to demonstrate because this seems like something that I would do. I'd be like, okay, well, let's do this. Let's call all the LAN networks in my company 172.30 networks, and I'll have all the WAN networks be like 10. Right? You following me? So that way I can just do a show IP route and be like, oh, those are WAN links because they start with 10. And oh, that's a LAN connection because it starts with 172.30. So over here I go, okay, no. Actually, I want this to be 172.30.10.0/24. And I'm like, oh, this is so great. Well, here's the problem. Router 3 is like, hey, I've got the 10 network, and backbone router's like, hey, I've got the 10 network. Let's auto summarize to death. Right? Because what's going to happen is they're both going to try and advertise as if they've got this. Routers will see that advertisement and they're like, whoa, router 3 is like, hey, man, you're telling me the same thing I'm telling you. There's a routing loop. Kill the relationship. Tear it down. We cannot be neighbors because we are obviously duplicating routes back and forth. Blah. We don't want that. Right? So that's the first thing. If you don't design your network to the way that Cisco, or best practices, I should say that you should, then auto summary can blow things up. However, even if it didn't blow things up, for me, I'm like, I don't like auto anything. I'm always like, yeah, auto and not use it. I would feel personally much more comfortable doing it all by myself. I want to type in the summary routes where the summary routes go. So something I always type on EIGRP. It's almost like before the network command. I do it before anything. No auto summary. Right? That's the command. Turn that feature off. Matter of fact, in the later versions of the iOS, like 15, it's somewhere in the iOS 15 dot something. I can't remember the exact version number, but don't worry, Cisco promises that they won't test you on what version of the iOS introduces the feature, but they actually turn auto summary off by default because they sat down with me and I said, guys, we got to do this, and so they did. So router 3, let's hop down there. No, trust me, I do not carry that much sway. I had to, I thought, someone might not think I'm joking. I really, no, I didn't sit down with Cisco and tell them how it was. But boy, I'd like to. Let's get into global config and I'll do router EIGRP. It's the raceway, right? Starting off with the raceway just made me this way. I'm going to do network 10.0.0.0. I'm going to type this in before the no auto because I want to show you, and this is a good reason to type the no auto first. As soon as I do this, no auto summary, it's going to actually tear down the neighbor relation. It's like, oh, here, scratch that. Sorry. Let's resync. Let's bring up our neighbors again because now I've turned auto summary off. So really simple way of turning on EIGRP for router 2 and router 3. So basic verification, right? Let's go into router 3 and just do a show First command I always type, like even before I check out the routing table and see what's up there, I'm going to type in show IP EIGRP neighbor. I mean, this is, let me get a little bigger here. This is like my show IP interface brief for EIGRP. I love this command. It's like, okay, I found a neighbor. First off, I've got, this is actually very poorly documented. This little H, people are like, oh, is that hop count? No way. You can never have a neighbor more than one hop away. So this is actually handle. All it means is this is the very first neighbor that I've learned about. Next neighbor will be 1. Third neighbor will be 2. Well, wait a second. Second neighbor will be 2. You get what I'm. So this is the address I'm talking to, the interface, hold timer. This is how long before he's dead, and that's because I can do a show IP EIGRP interface and say, okay, well let's wait a second. That's show IP EIGRP. No, I'm thinking show IP protocols. Well, this is a good command because you can be like, oh, hey, this interface, I've got this many neighbors and all that. What I was really thinking is show IP protocols. Because this will tell me I've got EIGRP. Why am I blanking out? EIGRP hello timer should be once every 5 seconds. Why am I not seeing that? Okay, I checked. EIGRP is one of the weird ones. All the other protocols show their timers under show IP protocols or show IP like OSPF interface or things like that's where they're at. But if you do a show IP EIGRP interface, and you got to include the detail keyword. And what you'll see is the interface itself, and that's where you'll see the hello timers. And so these EIGRP routers are saying hello once every 5 seconds. Let's get back to where I started. Once every 5 seconds. So it's saying if I don't hear from you in 14 seconds here, but in essentially 3 hello timers or 15 seconds, I'm going to consider you dead. Then you start diving into the kind of the stuff that's not as valuable, like, well, how long that neighbor's been up, the source round trip timer, which is how long it takes to get from that neighbor and back, because that helps gauge the hello timer to say, okay, well, we can't. You got to at least wait for the packet to get there and back before you consider them dead, if maybe you're going to miss that. So you get into all the other stuff. But primarily, first command I type after I configure EIGRP is I want to see my neighbors. They're looking pretty. Then I'll go in and do a show IP route, and I'll go, now I feel good. Okay, so from router 3's perspective, somewhere around here. Router 3's perspective, he is seeing 10.1.25.0 and 24.0, which is this guy. Let me grab my pen. Man, I'm hitting keys on the keyboard, and now I've got green lines. What is that? All right, there we go. So again, from router 3's perspective, we've got EIGRP enabled, and he is seeing this 10.1.24.0, a not directly connected network, as well as 10.1.25.0, this network behind there. So now he's learning about these networks. Okay, I'm ready. Let's check out the backbone router. Bring him up in a micro-sized window, and let's do a quick show IP interface brief. Get our bearings here. Okay, we've got, so to simulate all these little corporate networks, which these would just represent VLANs, whatever else you have at the corporate organization. I'm just using loopback interfaces. But then I've got my 2 serial links. So let's bring up the neighbors first, right? Let's say hello. Router EIGRP1. And we'll do network. So let's see here. We've got 10.1.24 and 10.1.34. I want to show you an option that EIGRP gives you, a little more specific. So I can say 10.1.0.0. Now, if I hit the enter key right here, EIGRP is going to oh, you must have messed up. You must have meant the classful 10 network. And if you go back and do a show run, it actually will take the 1 out of there. It'll just say, oh, you meant 10.0.0.0 if you typed it that way. But you can follow this up with a wildcard bit. So I'm able to come in here and say, okay, 0.0.255.255, just like we can with OSPF, and say, okay, these are the significant ones. So look for 10.1. So that way, if you add some other 10. Something else interface, it's not going to automatically run EIGRP. And again, remember, it's sending hellos and advertising those networks. So now the backbone router, I'm going to do a show IP EIGRP neighbors. It's got 2 neighbors. Again, the handle, just which one was learned first, that I'm seeing there. And then let's do a show IP route. And we're seeing the routes there that are being learned from the neighbor. Now check this. Ooh, Ooh, ooh. So we are seeing two separate routes to the 10.1.2 network down here, showing up in the routing table. Now this is actually something interesting. Let's do a show IP EIGRP topology. Remember that from talking about the concepts. Remember the topology table is everything EIGRP knows about. So it's seeing right here, okay, I've got this 10.1.2.0, and I've got two successors. Remember the terminology? Successor means this is my primary. It promotes it to the routing table. So it's like, hey, I've got two best routes. Now, right below that, notice this guy right here, 10.1.25.0. I've got one successor. So let's figure out where that is. Let's kind of get the realm of our topology. So 10.1.25.0, I'm trying to squeeze it all in. I can't. It's this network right here. And it says, okay, I've got one successor. This guy is the successor. This guy is the feasible successor. Now, in this table, it never shows you, I've got one feasible successor. It just says I've got one essentially primary, and by seeing two here, I'm like, oh, okay, well, so that means that the second one, whatever it is it must be a feasible successor. Now, how do I know that it's this one is the successor and this one is the feasible successor? Check out these numbers, right? Big numbers, huh? So this represents the feasible distance of that route. And notice it says one successor, the feasible distance. Come on, review that terminology with me. Feasible distance is how far it is from me. Me being the backbone. I don't know why I keep thinking black box when I see BB. The backbone router, it is this far away, but using the k-value formula. And I look here and I go, oh, okay, so that's this one, because that matches. So I say, okay, that's the primary. So that's the feasible distance right there. This is the advertised distance. So when this neighbor advertises it knows about the 10.1.25, it's like, and it's this far from me. And then once it crosses the WAN link and all that, then the backbone router says, well, it's this far from me. So it's like, okay, well, you're good, little router friend, but you're not as good as this one. So this one's going to end up in the topology table. Whereas this one, it's like, hey, I've got two paths to this network and they're equal. Now, you might be looking at the bandwidth being like, no, they're not. And you're right, they're not. It's just that Jeremy forgot to set the bandwidth on there. That's one of the things I had. See, you might say, Jeremy, do you like pre-plan all this stuff? Like you must have methodical ways and all that. Let me show you. There's my plan. I used to have a big old monitor where I could move it to the side and hide it to where I could like keep my eye on it as I'm doing things. But the new monitor I have is amazing. I can write on it. That's its claim to fame. But it's not as big as my other monitor, so I can't really hide my notes. So this is kind of my notes of what's going on. So let's set the bandwidth, right? So let's quickly get our bearings. I'll do a show CDP neighbors. And I've got router 2. Okay, so router 2, let's squish this down, is right here, 128 kilobits per second, and router 2 is out serial 0/1. So we'll go serial 0/1, and we'll do bandwidth 128K. Now, we want to do this because if we don't, the router's going to think every interface is a T1 line. So let me just verify. Do show interface serial 0/0, right? And bam, right there, bandwidth, 1544 kilobits per second, or 1.544 megabits. That's a T1 speed. So, this one we've fixed. It's now 128K accurate. So let's go into interface serial 0/0, which is the one connected down here to router 3. And that's 256 kilobits per second. So bandwidth, 256K. And it's in kilobits per second. So now, on most iOS versions, it just will start taking effects. Let's do a quick show IP EIGRP topology again. And now look at this. It's fixed it. So there was once upon a time two different routes to 10.1.2.0. So I can look right here, 10.1.2.0. Now there's just one. And check out, do you get the feel? Ooh, look at that. Feel it in your gut, right? I'm looking at that feasible distance, and that's about half as much as this one, just like 256K is about double the bandwidth as that one. So the 256K, and I know it's a logic game, right? It's like, this is messing with me. 256K comes in less on the metric, so that represents the leak. But look at the advertised distance. Look at that. So, I mean, just by looking, like if, pretend you didn't even have a network map behind you, you could look at the topology table and be like, ooh, I've got 2 routes to that network. One of them made it into the routing table, and that's going to be the fact now. If I do a show IP route, we won't see that little load balance world anymore. It's gone. One of them made it into the routing table, and I look and I go, it was this guy right here. He's the one that made it in. Now, this guy down below, he ended up sitting there as a feasible successor, but looking at the advertised distance for each one of them, the advertised distance is saying, they're the same. So I can mentally piece together the topology behind the scenes of what's going on. Now, usually when you do bandwidth statements, you'll do a clear IP EIGRP neighbors and just kind of do a quick reset, relearn it, or you can even completely reset okay, same command. I was saying the autonomous system, so we can choose which link to reset and all that. But that's when it's all said and done. The reason I did that is because I knew I was going to get emails, because I know some of you are really smart and you were looking and you're like, it doesn't make sense, Jeremy. You said before that that one was the best and it's broken. Hello, broken. Well, that's just because EIGRP is like, okay, someone changed the bandwidth on me on the fly. So once we reset the process, it's like, oh, okay, I'm filling in the right one. Okay, so that just kind of fixed all that. So looking at this, topology table, hugely valuable to understand. But now let's look at router 2 and router 3. So check this out. I've got router 2. I'll do a show IP route. Oh, wait a sec. I haven't even enabled this all the way yet. Router EIGRP1, and let's go network 172.30.0.0, right? Class B network. Let it run on all that. Okay, now let's check it out on router 2 after EIGRP does its little gig. I'm waiting. Where's my update? Where is my update? 172.30. Did I do that? Hang on. Let's shoot over here and do a show IP EIGRP interface. It's usually pretty quick. No, they're all there. Oh, was this there the whole time? I was missing it. It was even what my demonstration. So I've been hitting the up arrow. There it is. There it is. There it is. I'm like, where are they? What just happened there? Yes, you. It auto-summarized. Exactly. It auto-summarized all of those networks because, just like I was saying, it's saying, oh, 10 network, and I did not turn off auto... Nice, Jeremy. I did not turn off auto-summarization. See, when I get all excited, I just close Windows. All right. Let's go in global config mode, router, EIGRP1, no auto. No auto. Reset those neighbors, buddy. Bam. They're resyncs. Now we can come over there to router 2, and now this glossy summary route will be replaced by all the more specific routes. See that? Good. So auto summary is now off, and I feel better because auto summary just is a little bit too creepy for me. Now, I want to show you something. This is going to be really interesting, and I want to do this purposefully. So let me do a show IP route. On router 3. Notice both routers, right, have all of these routes, right? Now let's look at the lesser one. That would be okay. Router 2 has the worse link, right? So this link is not as fast. So, as a matter of fact, let's just look at router 2 again. I didn't even notice. Okay, so it's still choosing its serial link. It's figuring, okay, it's more costly to go across the fast Ethernet than out the WAN link than just go out the WAN link myself. So yes, so it's making the wise choice. But I want to show you something that can easily mess you up. So I'm going to go into the backbone router, and I'm going to do a summary route. So let's do a show IP EIGRP neighbors. So it's seeing router 2 on serial 0/1. Again, let's do a show CDP neighbors. Might be a little clearer. Router 2 is on serial 0/1. Again, router 2 has the worse link, right? So I'm going to go into serial. I'm going to label this. So this is serial 0/1. So I don't have to keep orienting myself. 0/0. So I'm going to go in. Let's see. Where do I want to go in? I'm going to go in right here first. I want to show you something. I'm going to put a summary route here. Because with EIGRP, summary routes are done on a per interface basis. So I'm going to go under the backbone router. Let's bring that guy up and go into serial 0/0, which again, I just want to emphasize serial 0/0. This is the better route, right? This is faster. We want router 3 to go that way. Yeah, I'm really pointing you in on what's going to happen. We want router 3 to go that way, right? So I'm going to summarize that router first. So let's go in. Here's the command. This is, okay, now I want to summarize. I'll do IP EIGRP, or actually IP summary route, summary address. EIGRP, and we'll say autonomous system number. So it's saying, what do you want to use as a summary address? Now we could get fancy. I mean, we could say, okay, I'm looking right here. I don't want to just use a /16. That's too broad. But one of the problems is this guy. So let me just show you how I would do this. I would say, okay, what's my binary increments? Okay, I've got 128, 64, 32, 16, 8, 4, 2, 1. Right? Are you hanging with me? Okay, right? Subnetting, binary, right? These are the increments. So I'm going, okay, well I can take an increment of 8. And that would do, okay, 172.30.0.0. If I'm starting there and I use an increment of 8 in that octet, then the next one is going to be 172.30.8.0.16.0. I'm just adding 8. This is Jeremy's quick subnetting process. And initially it's like, oh, great, that's perfect because 8 is right there. Well, no, actually, no, it's not. Because if I use an increment of 8 to summarize, what I'll do is, not 172.16, 172.30.7.255. I would actually encompass, this would be my summary address that I just cut right through with my line. This would be my summary address. So that would lop off. Like these would all be summarized, but I would lop off this guy. So that one would be advertised in as an individual route. So you might go, oh, well, okay, then why not use an increment of 16? Okay, well, if you use an increment of 16, 172.30.0.0, and I start saying, okay, .16, .32, whatever. I'm going way too far. But then my range goes 172.30.15.255. So I'm cutting into the text there. So if I use that increment to summarize, then the big problem is now I've encompassed too much. I've actually got 0 through 15. You see what I mean? So you might say, well, what's better? Well, it depends on your network plan. I would say, unless you really plan on the headquarters growing, my thought is it would be best to summarize this chunk, right? And allow this one to be advertised individually. Because you know what? Having 2 routes in the table, one summary address here, and then this individual route is a lot better than having 9 total routes, because we're counting from 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 total. You get the point, right? So okay, if I want an increment of 8, how do I figure out the summary address? Okay, well, how many bits have to be activated to get to that 8? 1, 2, 3, 4, 5, right? So that's my subnet mask I'm going to use. So actually, I can come up with a summary route to where I'm saying, okay, 172.30.0.0. You're like, okay, Jeremy, what are you doing? Hang on. Originally was a /16, right? But I'm going to add 1. So instead of saying 1, I'm going to say 17, 18, 19, 20, 21. So 172.30.0.0, and I'm just adding these onto the original 16. So /21 is the summary address that will match just this. Now, okay, prove it to me, Jeremy. Okay, 172.30.0.0. What is /21 as a decimal? 255.255. So it'd be /21. So it'd be -3. 248, right? Oh, I want to work it out now. So 16. So dot 16 dot. Okay. 17, 18, 19, 20, 21, 0, 0, 22, 23, and then dot 24. Wait, is that right? Is that? Yep. I'm talking too fast. It's not right. I forgot a 0. There we go. So that's what a /21 translates to in a decimal. So that would be 255. Yeah, that's right. See, when you're trying to go fast, you can make mistakes. So that's my summary address. So if I go here and let's prove it with the configuration as well as the whiteboard. Let's go to the black what is this? The BB router, and I'll do 172.30.0.0. What's the summary mask? 255.255.248.0. And you can change administrative distance. You can get into things like a leak mag. We're not even going to go there. I mean, we're just sending a summary address. So now the backbone router is saying, okay, I'm sending this summary address encompassing these first 8 networks, 0 through 7. Is one. So let's verify it. Let's go over to router 3 and check it out. I'm going to do router 3 show IP route. Okay. Now, what's going on? Do we make a mistake? How come I still see all these individual networks here? Oh, wait a sec. Oh, this is exactly what I wanted to show you. So take a look at router 3. Let's analyze what happened. First off, do I see the summary route anywhere? Yes, I do. It's right there. See it? 172.30.0.0/21. You're going, okay, so you're seeing the summary route, then how come it didn't suppress all of these specific ones that kind of fall under that summary? That's the whole goal of summarization, is to smoosh down the routes, right? But we didn't. We've got all of those routes plus. Well, in truth, it did. Look at what interfaces all these networks are reachable on. Oh, wait a sec. They're coming in the fast Ethernet 0/0. Wait a sec. Hang on. Let's draw this out. So what we did is we said, okay, send the summary address 172.30.0.0/21 right here, which it did. So I'll just put summary, right? Which it did. And it suppressed all of these routes. All of these guys, chunk, are no longer being sent out this interface. Here's the problem, though. All of those individual routes are being sent out here and are coming in right there. Okay, so you're saying, okay, well, but that's the worser. I'm going to use a word, right? That's the worser. That's the bad link. Why would it choose to go that way to reach all the? I mean, it's saying I want to go that way to reach all of those guys now, right? Instead of using my faster serial link. Or maybe the question is, well, which one is it using? Is it using this one to reach those networks, or is it using these individual routes? Well, remember, and this I'm leading all up to this, rule number 1 of the routing table. Remember, the routing table is the best of the best. And rule number 1 is whomever has the most specific subnet mask. Most specific subnet mask always wins. I could put a static route, which from an remember EIGRP administrative distance of 90? Static route is like 1, right? So it's like, this is a killer route. It's amazing, and it's a believable, a static route for this same route going that way, and the router still wouldn't use it because the only reason it goes to the administrative distance is because the most specific route is tied. So it's saying, okay, then let's check the administrative distance. Okay, 1 would beat 90. That's where that would come in. But if the administrative distance is tied, that's where it comes down to metric, right? So the reason I'm doing this, you're like, okay, what's your big picture point? The big picture point is you got to be careful with summary routes, because I just optimized this network. Now, first off, you would probably do this in an outage window anyway. But if you didn't, what would happen is he says, okay, great, thanks for cleaning up my routing table, but now I'm leaving all of the more specific routes over here, now taking and saturating this lesser link to get to the corporate office. This one is sitting there idle, except for which one? The 8, right? The one that did not get in. I mean, it's like, hey, I've got a summary route here. Woohoo for me, but I'm actually not going to use it because I've got all the more specific routes, except for this one. Notice that's the only one still going out the serial link because it was not included in the summary. Okay, so how do we fix it? We do it right. We do it the whole way. We go onto the backbone router, and let's go underneath the 00/1, which goes to the other one, and now put in the same summary route. Okay, so now I'm suppressing these networks on both this link and this link. Now, that it's still being advertised around here, but watch what's going to happen. Now, router 3, let's hit the up arrow. Router 3 is like, hey, now we're on equal ground. I'm not believing that I'm not accepting that your route is better than mine because I see your cost now. No longer are we on this little most specific subnet mask tiebreaker. Now I'm looking at the administrative distance. We're all using EIGRP, so we're all tied at 90, right? So I'm looking at the metric, and I've got these all have a better metric. Are you seeing this? Are you feeling it? That's big. That's a big concept right there. So I'm going to just verify show IP EIGRP topology on router 3. and verify that router 3. Well, as a matter of fact, router 3, if you look right here, it's not even seeing the other routes coming in, and the reason why it's saying, okay, I don't even care about those as feasible successor is we're back to that rule. I mentioned that weird rule: if the feasible distance must be less than the advertised distance of the successor. So we're not getting that rule in this case. So those routes, the ones coming from router 2 to router 3, don't even show up in the topology table. Wow, that got deep. If you're like, whoa, what just happened there? All I really wanted to show you was the IP summary address command and be like, ooh, look, this is how we send a summary route. But it just got so much bigger and so much, I think, more valuable because it's like, oh, okay, if you send one here, more specific routes are believed from there. We start taking an inefficient path until we fix it. And so good stuff, but a lot deeper than I had originally planned on. Okay, so a couple more things I want to talk about. One is authentication. The other is passive interface. So authentication makes sure that the other side is who they say they are. So when router router 2 and router in the backbone router and right here, like I'm not too concerned about those guys needing authentication on this link because it's a point-to-point WAN link. The only way somebody's getting on that WAN link is if they come, bust down the door of my IT room, grab a shotgun, blow away the administrator, put their router on the line and configure it similar to router 2. Then we're not really concerned about our network. We're concerned about the dead admin. But this is a big area that we want to check out because this line represents a switch. We're expecting that there's perhaps users on here as well. And EIGRP is a really friendly protocol. It's like, hello, hello, hello. And anybody that comes in is like, hey, I want to be a neighbor. EIGRP by default is like, yeah, sure, come on in. Let's exchange routes. You're fully trusted. And, worst case, somebody could poison your routing table and really, take down the network or even pull off a man-in-the-middle attack and inject false routes. And it still gets ugly. We want to make sure that these hellos are protected. But EIGRP, I will say, doesn't make it as quick and friendly as OSPF. It's more robust in its config, but if you just want a quick authentication, it's not that. So let's start on router 2, which is right there. The way that you configure it is you go into the interface, and so I'll go into fast Ethernet 0/0, and you type in IP authentication. And it comes in, it says, okay, what is your mode? And it's like, well, for EIGRP, Autonomous System 1, there's only one mode. OSPF supported, remember, the clear text and MD5. Remember that from the ICND 1 days? EIGRP is like, why even go there? Why go with clear text? That is a worthless form of authentication. We will only support MD5. So you can see this command is kind of like a, well, duh. You have to type it, but it doesn't really do anything other than scratch that. Other than take down your neighbor. Think of this as turning on authentication. So we've gone in and we said, okay, EIGRP will now use MD5 authentication, and the other side's like, hey, so the very first hello that comes in, it's like, I'm sorry, you're down. Because you are not an authenticated packet. I can't trust you anymore. So obviously don't type that in a production world because we haven't configured what's called the keychain yet. So I'm going to do IP authentication. Notice it says keychain for EIGRP Autonomous System 1 is what? Now, you may remember back to ICND 1, OSPF does support keychains. However, you don't have to use them. EIGRP, you got to do it. So let's go the whole way. The beauty of keychains is in their robust nature. We'll do key space chain. And we'll name it. We'll do CBT chain. Right? It is case sensitive, so I've got to remember that is all capitals. So then we come into here. There's not much to this mode other than we type in our keys. So we'll say key, let's just go key number 1 is going to be the key string of secret ninja. That'll be our password, right? So now the robustness comes in that I can start setting up accept lifetimes and send lifetimes. I can come in here and say, okay, I'm going to accept this from this time, 1 o'clock in the morning on 1 January 2014. Just like keep going down the road and say, and it's an eternal key. So I'll accept this eternally, or I can say this is the time I stop accepting. So the big benefit of this is you can have EIGRP rotate keys automatically. right? So I can say key 1 lasts for a month, and the next month go to key 2, next month go to key 3, just by going into the accept and send lifetimes in this key mode. Now, if you don't care about the accept and send lifetimes, and honestly, I have seen in most environments, people don't. They set up authentication once unless it's a high security environment, and they're like, okay, that's good enough for me. MD5 hashing is pretty secure. So I can come out now. Now I'm gonna, before I forget, because both sides need the same thing. Let's go into the other side. Keychain name doesn't have to be the same, but we do have to have, and I'll make it the same because I'll forget otherwise. But we do have to have the same key, both number and string. So I can't say key 2 is Secret Ninja and match it up with key 1 on the other side. Nope, it's got to be the same number and the same string. So I'm going to type in key string Secret Ninja. Enter. So exit out of that mode. So now we've got the keychain on both sides. Now, unfortunately, there's going to be a brief little blink of an outage unless you've got some kind of script that you can just paste it in all at once. So I'm going to go under, let's go under interface, fast Ethernet 0 size 0, and we'll do IP EIGRP, or what am I doing? IP authentication. Let's go mode for EIGRP. Autonomous System 1 will be MD5. Goodbye, neighbor. And then we'll do IP authentication. This is where our outage window just began. Keychain for EIGRP Autonomous System 1 is going to be CBT chain. Now, can I just take a brief little sidebar to mention the question mark? Do you see how I'm using the question mark? I'm not doing that just so you can learn it. I'm doing that because that is the norm when you're configuring a Cisco router. Unless you're just like, okay, I've got this list of commands I've typed in. But if you're trying to just go and, I mean, nobody remembers all the syntax for every command. So I'm just constantly hitting question mark. Do not think of yourself as like, oh, I'm lesser because you kidding me? Live on that question mark. Okay, so we're failing. Come on, we've got to save router 3. I'm going to go into fast Ethernet 0 size 0. IP authentication mode. EIGRP, Autonomous System 1, MD5, enter. So now it's like, okay, we're engaged, but I have no keychain applied yet. So let's add the second piece. You got it. Keychain, EIGRP 1, CBT chain. Right? Oh, I was going to hold my breath, but it happened so fast. So adjacency came up, and now we are using authentication. Again, this is good. We're authenticating our neighbors, at least where it matters most. Now, does it hurt to configure authentication here? No. It's just one more thing that it's kind of like I go to the store to buy a lawnmower. Actually, this was about 6 months ago. I went to the store to buy a lawnmower, and they had one with the automatic drive, where it's like, oh, I don't even have to push this lawnmower. It just kind of drives itself. And I talked to the Home Depot guy, and I'm like, do you recommend that? He's like, no. but it pushes it for you. Looking back, he probably was like, "Are you a man? Like what's your problem?" But he was like, "Nope." He's like, "That is just one more thing that can break on this lawnmower." And I'm like, "You know what?" And it probably will. It's one of those things. Like, why do I need my lawnmower to drive itself? That's just, how much can go wrong? So same kind of thing here. You get the point, right? If I configure authentication there, and I don't really need it, sure, it may make me feel better, but it's just one more thing to go wrong. So I'm, I want it there. It's a user community. Now what about this? Let's pretend that there is no. This is a loopback interface, but pretend it's not with me, right? There's users here, but I will never form an EIGRP neighbor there. Should I configure authentication? Nope. I'm going to go into that router 2. And you might remember this from OSPF and ICND 1. But I'm going to router EIGRP 1. And let's do a quick show IP interface brief. So I can remember which one it is. It's this guy right here. So now a couple of strategies. If I just have these little onesie twosie interfaces that I want to be turned off, that's where I can come in here to the router and say, okay, passive interface loopback 0. What's that do? So essentially, remember I said the loopback command does two things. One, it sends hello messages, and two, it advertises the network. By using the passive interface command right here, it turns off number 1. It's still does number 2, so I'm still advertising that to the rest of the world. Otherwise, I would just remove the network statement for that, and now it's like an invisible network. Nobody knows it's there because I don't advertise it anymore. So it's still doing number 2, but it's no longer sending hello, so it is impossible to form a neighbor relationship on that interface. Whew, okay. It was a little longer, but so good. So good. So I've got to bring up my little cheat sheet. What did we talk about? Oh man, so we did the basic EIGRP configuration. We talked about no auto summary, using the wildcard mask instead of just the classful network command, so we can specify exactly what networks to run on. We looked at the verification, show IP EIGRP neighbors, show IP protocols, show IP EIGRP topology, show IP route. I mean, a lot of big show commands to verify everything is working as expected. We did the summary routes, and boy did we do the summary routes. I know you're like, there's 2 number 4. Yeah, it's just because I think about things and squeeze them in later. So there's 2 big summary routes to where we dove into all the specifics of how those works. We did authentication and even added number 6, which is the passive interface command. Now I mentioned last thing I'll say. Is some people, I said some people like to do the little onesie twosies. Others will go in there and do passive interface default. See that last one right there? Which turns it off on all interfaces. And by the way, this is Cisco's recommendation for good security. And then I can come in and say no passive interface for fast Ethernet 0/0. Turn that one back on. No passive interface for 0/0. So you kind of come in and turn on the interfaces that you want to turn on. Does that make sense? So that's another approach to the passive interface command. Good. Well, I hope this has been informative for you, and I'd like to thank you for viewing.